Hello students, welcome to SAFAL, Seeker Academy for Ace Learning. So today we are going to discuss a new chapter, that is real numbers. So this chapter I have divided in 4 parts. In the first part we are looking at Euclid division lemma, how to find HCF using Euclid division algorithm. In the second session and third session we are looking at fundamental theorem of arithmetic and question based on that. In the last and final session, we are looking at decimal representation of rational numbers and irrational numbers. So let's start with first session, that is Euclid division lemma and how to find HCF using Euclid division algorithm. So before starting Euclid division lemma, it's very important for us to recall the number what we have studied in class 9th. So the first number what we have studied is natural numbers, which we used for what? Counting purpose. So the numbers like 1, 2, 3 and so on, 4, 5, 6. Capital letter N is used to denote natural numbers. Then we saw that if you take 0 with natural number, we get a set. The name of the set is what? Whole numbers denoted by W. So in this region only 0 will come. The next set or the next number what we have studied is integers. So integers are nothing, natural number, negative of natural number and 0. So natural number is taken, 0 is taken, then negative of natural number we are supposed to take, that is -1, -2, -3, -4 and so on. It will keep going. Capital letter I or Z is used to denote integers. The next number which we have studied after integer is rational numbers, which are denoted by capital Q, and the numbers which are written in the form P by Q are called rational numbers, where P and Q are integers and Q not equals to 0. So the numbers like 1 by 2, 3 by 7, -9 by 11, any number which you can write in the form P by Q, where P and Q are integers, it comes under the category rational numbers. So the next collection we have is irrational numbers, which are denoted by Q dash, and what kind of numbers will come here? √2, √3, √5, similarly √7.8, pi, etc. These all numbers will come under what? Irrational numbers. We know that when we club a rational and irrational numbers together, then the collection what we get, we call it as real numbers, which is denoted by capital R. So this is the brief recall of number system what we have seen in class 9th. Now why I have represent number like this, so that you could able to do true or false question based on this. Now here I am making a statement, every natural number is a whole number. So I can say yes, it's a true statement. Why? Because green circle is inside the blue circle. But if I am making a statement, every whole number is a natural number, so I can say this whole number 0 is not inside green circle. So that's why every whole number is a natural number is a wrong statement. So after looking at brief recall of number system, now I want to look at two numbers which are classified under natural numbers. So the first number is prime numbers. So natural numbers which have exactly two distinct factors, very important. Those natural numbers which have exactly two distinct factors, they are classified as prime numbers. So the number like 2, 3, 5, 7, 11, 13, these all are what? Prime numbers. Now you can see that I have highlighted 2 in bold. You need to keep in mind that 2 is the only even prime number. Rest whatever prime numbers we have, they are what? Odd. So natural number which have exactly two factors and the two factors should be distinct are called what? Prime numbers. The next class we have is composite numbers. Those natural number which have at least 3 distinct factors, very important. एटलीस्ट 3 डिस्टिंक्ट फैक्टर मीन्स व्हाट, कम से कम उनके पास 3 डिस्टिंक्ट फैक्टर्स होने चाहिए. फॉर एग्जाम्पल 4, 6, 8, 9, 10, 12, these all have what, 3 or more than 3 distinct factors. For example, you can see 4 goes by 1, it goes by 2, it goes by 4. So it goes by 3 distinct numbers, hence it's a composite number. Again, I have highlighted 4 and 9 in bold. The reason is 4 is the smallest even composite number and 9 is the smallest odd composite number. Now one thing you can notice from here, the number 1 is not in the list of prime, not in the list of composite numbers as well. So 1 is neither prime nor composite. So this brief recall of number system I want everyone to keep in mind. So now we can start off with Euclid division lemma. So the first question arises, what is a lemma? First time we are hearing this word lemma. So lemma is a proven statement used to prove another statement. It's a proven statement used to prove another statement or theorem. So let's take up Euclid division lemma. It states that given two positive integers a and b, there exist unique integers q and r such that a equals bq plus r, where r is greater than or equal 0 and less than what, b. So ये division की बात करता है. To illustrate by taking one example, let's say the two natural numbers or positive integers I'm taking is, let's say 8 and let's say 5. So if I'll divide 8 by 5, so 5 ones are 5, right? What remainder I'll get? 3. And I can see that 8 can be written as 5 into 1 plus 3. So this was basically A, B, Q and then R. So what long division method we have studied? So here we have dividend, divisor, quotient and remainder. So we know that dividend equals divisor into quotient plus remainder. So Euclid division lemma talks about that itself. So A is basically dividend for us, B is divisor for us, Q is quotient for us and R is remainder for us. So in this specific example which I took, 8 was A for me, 5 was B for me, quotient we have got it as 1, remainder we have got it as 3. So you can see that 5 into 1 plus 3, it's basically what, 8. So this simple rule is basically Euclid division lemma. Let's take up a question based on this lemma. Apply Euclid's division lemma on 7 and 18, considering 7 as divisor, find the remainder. So we need to divide 18 by what? So let's write the solution for this. So we need to divide 18 by what? 7, because the question said take 7 as divisor. So 7 2s are 14. So the remainder will be 14 minus 18 minus 14. So that's going to be plus 4. So here I'll get it as what? Plus 4. So again 18 is dividend, then divisor is 7, quotient is 2 and remainder is what? 4. You can see also 7 2s are 14, 14 plus 4 is what? 18. That's what we have. So they are asking remainder, so remainder is going to be what? 4. Okay. So the simple rule is very useful in many practical situations. So let's move ahead. Now we are trying to understand HCF and how to find HCF using Euclid division algorithm. So the first thing is, what do you mean by algorithm? So algorithm is a step-by-step procedure to accomplish any task. So कोई भी टास्क आप ले लो, उसके लिए जो स्टेप बाय स्टेप प्रोसीजर है उस टास्क को कंप्लीट करने के लिए, उसी को अपन क्या बोलते हैं? एल्गोरिथम. नाउ हियर आवर टास्क इज टू फाइंड HCF. Okay, so first let us understand what do we mean by HCF. So HCF stands for highest common factor and it is the largest number, very important, it is the largest number which divides a given set of numbers. To illustrate with an example, HCF of 12 and 15 is what? 3. The reason is 3 is the largest number which divides what? Both 12 and 15. You cannot have a number greater than 3 which divides 12 and 15 exactly. So highest common factor means it's the greatest number which divides a given set of numbers. So now, and one more thing, the HCF of two numbers we denote it by HCF in the parenthesis a comma b. For example, HCF of 12 and 15 is 3, represented like this. Similarly, HCF of 6 and 11 is 1. So now we'll see what are the steps to find HCF of two given positive integers. So let's take the two positive integers as a and b such that a is greater than what? B. Now in step 1 we are supposed to apply Euclid division lemma to a and b, and we need to write a equals bq plus r, where r will be greater than equals 0 and less than b. Now if you are finding that r is 0, then b is only going to be what? HCF of a and b. And if r is not 0, then again we need to apply Euclid division lemma on b and r, that means divisor and remainder. So this process we need to follow till remainder becomes 0. The stage at which remainder becomes 0, the divisor at that stage is only what? HCF of a and b. अब ये चीज काम इसलिए करती है क्योंकि HCF of AB is same as HCF of B and R. So keeping Euclid division algorithm in mind, now we'll do two questions to illustrate how we are finding HCF using Euclid's division algorithm. So the first question you can see on the screen, find the HCF of 404 and 96 using Euclid's division algorithm. So let's write the solution for this. Now 404 is greater than 96, so I can apply Euclid division lemma on 404 and 96. So that's what I have done. So 404 is 96 into 4 plus 20. Now here why only into 4, why not into 5? Because if I'll multiply by 5 it will go beyond 404. So that's why 96 into 4 plus 20. Now I can see that remainder is not 0, it's 20 and divisor is 96. So again on 96 and 20 I need to apply Euclid division lemma. So that's what we have done. So here again remainder not 0. So again on 20 and 16 EDL will be applied. So we are getting 16 into 1 plus 4. Again remainder is not 0. So 16 and 4 I need to apply. So you can see that at this stage the remainder becomes what? 0. So we know that at whichever step the remainder becomes 0, the divisor at that stage is only what? HCF. So here divisor is 4. So that is only going to be HCF of what? 404 and 96. It's pretty simple. Let's take one more example. Find the HCF of 867 and 255 using Euclid's division algorithm. अब बच्चों यहाँ पे भी आपके लिए बहुत आसान है 867 and 255. So I can see that 867 is greater than 255. So I'll divide 867 by 255 and I'll write the expression. So 255 into 3 plus 102. Now I can see remainder is not 0. So divisor, that is 255, and remainder. So again EDL will be applied on that. So 255 equals 102 into 2 plus 51. So again my remainder is not 0. So I need to apply on 102 and 51. So there I can see that 51 into 2 is basically 102. And here remainder is becoming 0. So whatever my divisor is there at this stage, which is 51 in this case, that is only going to be my HCF. So HCF of 867 and 255 is what? 51. So it's very simple. Just you have to make use of Euclid division lemma and check when remainder is becoming 0. Whenever remainder is becoming 0, at that stage whatever divisor is there, that is only going to be HCF. Let's take up one more problem. Now here you can see that three numbers are given. Let's call this as n1, n2 and n3. So we are able to apply Euclid division lemma on what? Only two numbers. So out of three given numbers, I can take any two number of my choice. So let's say as of now I am taking 6 and 72. 6 and 72. So I can find HCF of 6 and 72 by EDL. So 72 is 6 into 12 plus what? 0. So I can see that my remainder is becoming 0 here. So whatever my divisor is there, which is 6, that is only going to be my what? HCF. So that means HCF of 6 and 72 is what? 6. Then whatever HCF you get, that you take with the third number. So now I am taking HCF, that is 6, and third number, that is 120. So 120 and 6 I am applying EDL, so 120 divided by 6. So 6 into 20 plus 0. So I can see in the first step itself the remainder is becoming what? 0. So whatever my divisor is there, that is going to be HCF. So HCF of 6 and 120. So that's going to be again 6. So I can see that HCF of 6, 7 and 72 is also 6, and HCF of 6 with 120 is what? 6. So the three numbers will have HCF as what? 6. So HCF of 6, 72 and 120 is what? 6. That means 6 is the largest number which divides 6, 72 and 120. So whenever three numbers are given, it's very simple. You take first two number of your choice, find the HCF. Whatever HCF you get, that HCF you take with the third number, find the HCF. Whatever final HCF is coming, that is only going to be the HCF of all the three numbers. Now, so the next note you need to keep in mind is, even though we have studied that Euclid division algorithm is stated only for positive integers, but it can be extended for all integers except what? 0. But we are not discussing there. It's out of the scope of our syllabus as of now, but you need to keep in mind it's applicable for negative integers as well. The next note is, Euclid division lemma and algorithm has several applications related to finding property of numbers. So some property of numbers are there which we can easily study with the help of Euclid division lemma or algorithm. So let's see some of them. So the first one you can see on the screen. So that every positive even integer is of the form 2q and every positive odd integer is of the form 2q plus 1 for some integer q. So we are supposed to show that every even number can be written as 2q and every odd number can be written as 2q plus 1 where q is some integer. So let's write the solution. So here we know that a number is said to be even if it is divisible by what? 2. So let's take the number as what? A, and divisor as what? 2. Divisor as what? 2. So as per Euclid division lemma, I can write A equals what? 2q plus R, where R will be greater than equal 0 and less than what? 2 divisor. So R has two possibility. R is 0, case 1, when R is what? 0. So when R becomes 0, then what you'll get? My number will become simply 2q plus 0. Now 2q plus 0 is 2q only. That means A goes by what? 2. Or A is a multiple of 2, I can say. So from here I can say A is what? Even. And I can see that when A is even, it is of the form 2q. Second case, when R is what? 1. So in that case A will be what? 2q plus 1. Now just now we have proved that this 2q number is what? Even. Now even plus 1 is what? odd. So that means in this case A is what? Odd. So here we are getting A as what? Odd. Okay. So we can see that when A is even, it is of the form 2q, and when A is odd, it is of the form 2q plus 1. So this is a standard result you can keep in mind. We will use in many questions. So let's take up the next one. Now here they are asking that so that any positive odd integer is of the form 4q plus 1 or 4q plus 3 for some integer q. Now this is a problem from NCERT. It's a nice question. It has come in previous year board exam also. So let's see how to do it. So here the clue we are getting from this number 4. That means we need to take a number A and we need to divide it by what? 4. So I'll write let's A is a positive integer and taking 4 as divisor. As per Euclid division lemma, I can write it as what? A equals 4q plus r. Again where r will be greater than equals 0, less than equals what? 4. So here r has choice r becoming 0, 1, 2 or 3. So let's look at each case. So case 1, when r is what? 0. So when r is 0, A will be 4q plus 0. Now 4q plus 0 is basically 4q, and this I can write it as 2 times of 2q or 2 times of m, where m equals what? 2q. Now just now in the previous example we saw that 2 times of any number is what? Even. So that means this is case of what? A is even. So when r is 0, A is even. Let's take up the second case when r is 1. So that time I will get A equals 4q plus 1. Now 4q plus 1, so maybe I can write 2 times of 2q plus 1 or 2 times of m plus 1, where m is what? 2q. So again I can see that since 2m is even and I am adding 1 to it, so this number is going to be what? Odd. So A is odd. A is odd in this case. Taking third case when r is what? 2. So when r is 2, so that time I can write A as 4q plus 2. Now 2 I can take it as common, so 2q plus 1, and this again I can write it as 2m, where m equals what? 2q plus 1, some integer. So again in this case I am getting the number as 2 times of some integer. So that means in this case A is what? Even. In this case A is even. Considering the fourth case when r is 3. When r is what? 3. So when r is 3, so A will be 4q plus 3. So maybe 2 I can take common, so 2q plus 1 and plus 1. So I can write it as 2m plus 1, where m is 2q plus 1. So now again here I can see that the number is of the form 2m plus 1, and this implies A is what? Odd. A is odd. So now I can see that when the number A is odd, so that time it is 4q plus 1, or when A is odd, in the fourth case it is 4q plus 3. The rest two cases is what? Even. So that means any positive odd integer can be written in the form 4q plus 1 or 4q plus 3 for some integer q. It was a nice question. Please keep in mind. So moving ahead, This is a problem from NCERT Textbook exercise. They are asking that use Euclid's division lemma to show that cube of any positive integer is of the form 9m, 9m plus 1 or 9m plus 8. Now by seeing this number you might be getting the clue that we need to divide by what? 9. But if we need to divide by 9, then we will have 9 cases, right? R equals 0, R equals 1, R equals 2. Similarly 3, 4, 5, 6, 7, 8. Till 8 we need to work it out. But it's not feasible to write that many cases. Since they are talking about cube, and cube of 3 is what? 27, which is a multiple of what? 9. So maybe I can take a number and I can divide it by what? 3. So that's what I am doing. So let us consider some positive integer n. So dividing n by 3. So if I'll divide n by 3, n can be written as 3q plus r. Now here r has possibility 0, 1 and 2, 3 possibility. So all 3 possible cases I am listing. When r is 0, n is 3q. When r is 1, n is 3q plus 1. And when r is 2, n is 3q plus 2. अब बात तो ये क्यूब की कर रहे हैं. So now we'll consider the first case when n is 3q. So let us find the cube of n. So first case when n was 3q. So I am cubing both sides. So 3q the whole cube is 27q cube. So 9 times of 3q cube, that is 9 times of m, where m is a positive integer. Second case when n was 3q plus 1, once again we'll cube it. So n cube equals 3q plus 1 the whole cube. So here I can make use of a plus b the whole cube. So a cube plus b cube plus 3ab into a plus b. So on simplification I am getting 9 times of some number plus 1. So this I am writing it as m. So 9m plus m. Similarly, the third case when n was 3q plus 2. So that time cubing both sides. So n cube equals 3q plus 2 the whole cube. So again a plus b the whole cube I am using here. So a cube plus b cube plus 3ab into a plus b. So on expansion and simplification I am getting 9 times of some number plus 8. So 9m plus 8 where m is a positive integer. So here I can see that cube of any positive integer can be written in the form what? Either 9m, it can be written in the form 9m, you can see here, or 9m plus 1 or 9m plus 8. So that's what the question was asking. It was a nice question. So taking up the last question of this session. Now here they are asking that prove that product of any 3 consecutive positive integers is always divisible by 6. So 3 पॉजिटिव इंटीजर को जो कंसेक्यूटिव है उनको मल्टीप्लाई कर रहे हैं और अपने को प्रूव करना है कि जो प्रोडक्ट होगा वो 6 से डिविजिबल होगा. So let's take up the solution. Now if a number has to be divisible by 6, it should be divisible by 3 and it should be divisible by what? 2. So first we'll take 3 consecutive positive integers. So we are taking 3 positive consecutive integers n, n plus 1 and n plus 2. Now I need to check divisibility by 3. So I am checking first divisibility by 3. So that time n can be written as 3q plus r, where r is greater than or equal 0 less than 3. So when r is 0, now we are considering the first case when r is 0. So n will be simply 3q, which is divisible by 3. Second number is n plus 1, so that will become 3q plus 1, not divisible by 3, and n plus 2, so again that also won't be divisible by 3. So this was first case when remainder is 0. Out of 3 number, 1 is divisible by 3. Case 2 when remainder is 1. So then n will be 3q plus 1, not divisible by 3. N plus 1, that means 3q plus 1 plus 1, that is 3q plus 2, that is also not divisible by 3. But n plus 2 if you see, so 3 cube plus 1 plus 2, that's 3 cube plus 3, so 3 times of cube plus 1, so this is divisible by 3. So that means when r is 1 also, out of 3, one number is divisible by what? 3. Taking the third case, when r is 2. So when r is 2, the first number will be 3 cube plus 2, which is not divisible by 3. When we take up n plus 1, so 3 cube plus 2 plus 1, that is 3 cube plus 3, 3 times of cube plus 1, that means this is divisible by 3. Again n plus 2 if you take, so 3 cube plus 2 plus 2, so 3 times of cube plus 1 plus 1, so here I can see not divisible by what? 3. So that means irrespective of the case where r is 0, r is 1 और r is 2, तीनों में से एक नंबर जो है वो क्या है? 3 से divisible है. So that means the product n into n plus 1 into n plus 2 is going to be divisible by 3. Now let's check divisibility by what? 2. So two possibility will be there, n will be either even or n will be odd, right? This number n what we have taken in the starting, so n has two possibility. So now we are checking when n is even what is happening, when n is odd what is happening. So when n is even, I can replace n by 2m in the product. So in replacing that, we are getting that 2 times of some number. So that means the product is divisible by what? 2. When n is odd, I can write n as 2m plus 1. So again taking up the product, so I'll get 2m plus 1, 2m plus 2, 2m plus 3. Now from this bracket I can take what? 2 outside. That's what I have taken. So when n is odd also, still the product n into n plus 1 into n plus 2 is divisible by what? 2. So that means irrespective of whether n is even or n is odd, the product is divisible by what? 2 as well. So since we can see that the product is divisible by both 2 and 3, it should be divisible by what? 6. It's a very standard result. You can keep in mind. It will help in many exam. Product of any 3 consecutive positive integer is always divisible by what? 6. So that's it for today's session. Thanks for watching. Please do like and subscribe the channel. And after this, you can attempt exercise 1.1. So then we'll meet in the next session with fundamental theorem of arithmetic. Thank you.